Hi, in this video we will be checking to see if two events are independent or not. And to check to see if they are independent, we have this test right here. And this is different from the independence equation that I gave you before. What this one says is if the probability of A occurring, given that B has occurred, equals the probability of A occurring, and if the probability of B occurring after A has occurred equals the probability of occurring on its own, then the event is independent. So we're going to go to MathXL and look at a few examples of how this can be used. All right, so this example says the table contains the number of men and women at a company who are managers or team members. Use the probabilities to determine whether events A and B are independent. A says we have a man, and B says that that person is a manager. So what we need to do to test to see if being a man is independent of being a manager is this test down here. Now these both say the same thing. We're going to find the same numbers. If they are independent, then these two are going to be equal. And these two are going to be equal. If they're dependent, then these two are not going to be equal. And these two are not going to be equal. So let's first see what these probabilities are, and then we will answer the question whether or not they are equal. So this is the probability of A given B. So that means the probability of a man given that the person is a manager. So since I'm only looking at the manager column, or sorry, manager row, that's this row right here, there are 4 men out of the 6 total. And it says I'm going to need to type these in with 3 decimal places, so that's 0.667 when I round that. And the probability of A occurring, so that's just the probability of getting a man, is 32 out of 48. And when I divide those, I also get 0.667. Right? So far it's looking like they are independent because these first two check out. Right? Let me clear this off and we're going to try the second one. Probability of B, that it's a manager, given that it's a man. So I'm only going to be looking at this row, sorry, this column. There are 4 managers out of the 32 total. And when I divide that, I get 0.125. And then I need to look at the probability of B, which is a manager, out of the total. And that's 6 out of 48. And when I divide 6 by 48, I also get 0.125. Since these two are equal, and these two are equal to each other, that means the events are independent, and I would just type in those decimals, and that would be the answer to that question. So let's look at one more. All right, this question says, a jar contains 8 large red marbles, 4 small red marbles, 9 large blue marbles, and 6 small blue marbles. If a marble is chosen at random, which of the conditional probabilities is larger? Probability of picking a red one, given that it's small, or the probability of picking a small marble, given that it is red. Now, this is not a test for independence. We don't just switch them around and see if they're the same. I will check back in on independence once I get finished answering this question, but we're just going to be looking at these 2 conditional probabilities to answer the question. So I've created a two-way frequency table down here, and across the top, I'm going to call this the large marbles and the small marbles. I'm going to call this the red marbles and the blue marbles. And then I'm going to fill in the numbers in my table. So it says I have 8 large red marbles. So that goes here. I have 4 small red marbles. I have 9 large blue marbles. And I have 6 small blue marbles. Right, so if I add these up, I get 17 marbles that are large, 10 that are small. I have 12 red marbles, and I have 15 blue marbles, and that gives me a total of 27 marbles. So the first thing, and I'm going to have to calculate each of these, so I'm going to calculate them and then see which one is bigger. So this is the probability that I get a small marble given that it is red. So since it's red, we're only looking at this row. The probability that it's small is 4 out of 12. So this is 4 out of 12. And it's going to ask me to reduce that, so that is 1/3. And I'm probably going to need a decimal to compare those. So that's going to be 0.3 repeating. Right, the next one is the probability that it's small, probability that it's red, given that it's small. So I am only looking in this column. There are 4 red marbles. There are 10 small marbles. So that's going to be 4 out of 10. And when I reduce that, I get 2/5. And that, as a decimal, is 0.4. So the question says, which one is bigger? And that's obviously the second one. So it says red given small is bigger. So I'm going to choose this one. Red given small goes in here, so 2/5. And small given red is 1/3. Now, I said this was not, we are not checking to see if these two are equal to see if we have independence. For our independence, what we would need to do, and let's just use this one, probability of red given that it's small, and we would have to compare that to the probability that it's red. And the probability that it's red, I take my total red, which are 12, out of my total marbles, which are 27. And I just want to compare them. So I'm going to do this decimal. And when I take 12 and divide by 27, I get 0.4 repeating. And those are not equal. So again, this question doesn't ask for it, but if it did, these would not be independent because these two numbers are not equal. Right, so hopefully that helps. If you have any questions, ask me in class.